It is time, is what I mean. It is time for us to start this show. Pre-show banter, it's been fun, but it's time to move in and let Roman get his wizarding on the keyboard and the mouse there to kind of explain some of these challenges to us and get things started. So, Roman, what is going to be our first challenge for today, and what level are we looking at when it comes to easy, intermediate, or advanced?
Yeah, let me pull it up. So every Flash CTF, with a few exceptions, we usually have 5 challenges. There are 5 general categories of challenges. Occasionally we have a miscellaneous, occasionally we have recon. Can you show my screen? Yeah. We might have some other categories, but generally we have these 5 categories, and throughout the different Flash CTFs, we just rotate the difficulties. So the first challenge, that's all, the point values correspond to the relative difficulty of the challenge. Sometimes during the competition, we actually change these point values because we might see that some challenges that we thought were really difficult ended up being a lot easier. And so we ended up, swapping the point values. But this time, this web exploitation challenge was kind of the easiest one. So it's called Treasure Map. It says, after several long years, you finally found yourself on board the digital buccaneer. You know the treasure must be close, but searching the ship's navigation hasn't helped at all. Can you steal the pirate's booty? Access the site here. So this doesn't really tell us exactly what the. I guess before you start university CTF, you have to kind of understand the concepts of what CTFs are. Most of you are probably kind of familiar with it, but if you've never done a CTF, CTF stands for capture the flag, and your goal as a participant for every single one of these challenges is to capture a flag. And the flag is just a string of text that in our case, usually starts with the words MetaCTF. It might have, other competitions have different formats. In some cases, there's no way for us to put the word MetaCTF and where we're putting the flag in. So there are exceptions, but in general, you're supposed to try and find the flag. And so even though this challenge doesn't explicitly say that you need to find the flag, that's kind of the implicit goal for every single one of these challenges. The description doesn't really say too much, but but after you look at the website, you'll start noticing a few kind of themes. It talks about the treasure, which we can probably assume is the flag, and it talks about searching the ship's navigation. So navigation is kind of a theme that we're looking at here, and I guess the treasure, the flag that we're trying to get. If we go to the website, usually when you start looking at web exploitation challenges, the first thing like I usually do is just right-click, view page source, right-click, inspect, start looking at all the network requests that are happening. This is an easier challenge, so that's probably an overkill for this one. And often I look at a website, I see that it has a database, it has something else, so I jump straight to SQL injection, and I don't even read the website. I just go in and start like plugging things in and trying to get it to work. And then
You're a
for
hammer
some
looking
challenges,
for a nail, huh?
yeah, and for some challenges like these, that's really not the approach. You just literally read the description, it'll give you the answer. And so my other approach wouldn't have worked here. But if you look at the website, it says, welcome to the ship. Somewhere in the site, we've hidden a flag. It isn't linked from the main navigation, so we'll need to do a bit of digging. So this this line right here tells us the task that we have to do in order to be able to solve the challenge. If you read more, if you kind of look through the different pages, you will see that it mentions things like sitemap. I think it mentions sitemap multiple times. It talks about sitemap.xml file that webmasters use. So this challenge is really about learning about what sitemaps are and just simply accessing the sitemap.xml file on the website. If you didn't see the word sitemap on the web page, the way you could approach this challenge is just kind of, do some Googling and look up, well, got it. Let's see, website navigation maps. You'll start seeing words like sitemap, You might also learn about robots.txt, which is a little bit different, but it's another tool that kind of might give you an indication of what's available on the website. So ideally, you solve those challenges by simply finding the word sitemap throughout this website and putting in here. But if you didn't know about this at all, the way we would approach this challenge is just to like do a bunch of Googling, do a bunch of search engine work, and try and find the file. So if you a lot of you might be familiar with a file called robots.txt. It's a standard file that I think a lot of search engines actually ignore right now. It's not really, they don't really follow. I think if you want a page taken off of the website, you need to use the meta tags on the page itself. And I've noticed that Google just kind of blatantly ignores this sometimes. But robots.txt is a standard file that a lot of search engines look at or used to look at in order to see which pages they're allowed to index. And so usually it's a very, it's a useful tool for you as a developer if you're trying to hide certain things from showing up on Google. But as an attacker, it's also a really good place to see all the files that the developer doesn't want you to find on Google. And so it also lists like the sitemap. Sitemap.xml, it's not quite a standard. Usually websites might have like sitemap, like pages underscore sitemap, or like there's no like explicit definition of what sitemap.xml is supposed to be called. But usually,
could you increase the font just a little bit?
Yeah.
There you go. Perfect.
And this is an XML file that just what websites put out for search engine optimization that lists all the different pages that they have on this website. And so right here, you see this treasure chamber page that if you go to it, it'll tell you the flag. Robots.txt, sitemap, I think they're one of the .well-known files. So if you want to learn more about this, well, no, you need to. Let's see, maybe there's a nice page. There's a handful of files that you'll often find on a lot of different websites. It's kind of this like standard set of locations where you can find, where search engines, different applications can find information about the website. And so, for example, there's, like I mentioned, robots. Oh, is it not? Is robots.txt not one of these? That's surprising. But things like security.txt, yeah. Often when you, for example, if you find a vulnerability on a website and you're trying to report it, I mean, let's just pick a random website, like google.com. Let's try going to security.txt. Oh, doesn't work. What's a random security company? A random tool company. Trusted Sec.
We'll pick on Dave Kennedy today.
Yeah, let's see how well they. So they don't have, but let's see if they have that well known. Okay, well maybe this defeats my point. Yeah, wow. Okay, well, a bunch of websites, especially if they have some kind of tool, if they have a responsible disclosure program, they'll usually have the security.txt file available. I mean, let me see if we have it. I feel like we do. Yeah, okay. So it's a file that kind of just tells you how to report vulnerabilities. Somebody says,
could you increase that font so we can see that?
Yeah.
There you go.
It just tells you kind of some information about where to report security vulnerabilities to.
Very cool.
And so just one of standard file names that you'll often find. Oh, I see. Yeah, Google wasn't well known. Yeah, Google has it too. There it is. You just had to add the .well known folder. Yeah, so that's the intended solution, one of the solutions. Generally, we don't recommend this during CTFs because it can take down our infrastructure, especially if everyone does it. But like brute forcing the file names in the website using tools like dirbusting, unfortunately, for some reason, as CTF organizers, usually we create challenges in such a way that dirbusting wouldn't make any impact. And for some reason, CTF players just like the first tool they jump to. I guess probably because it's effective. But you could have used Derby or whatever. There are like hundreds of those tools to fuzz the different pages on the website.
Yeah,
And
I would
you
assume
find,
even if you threw like a NIC2 scan at it, that does some directory fuzzing as well, just out of default. So
yeah,
people are probably just it's web application stuff. Cool. I'm going to grab my web app tools. That's going to be like NIC2. That's going to be like GoBuster, FairXBuster, and so on.
yeah,
So because that's their methodology that they've learned from seeing how tools work, instead of going, well, because I think what Roman is really getting at here, and is a great takeaway from this challenge, is when you plop down on either a CTF, or if you're doing bug bounty, or you're doing a web app pen test, or whatever the case is that you need to like really navigate that site manually. You need to take some time and sit there and go, okay, what page goes where, map this stuff out. And sure, you could be running this through Burp Suite so that you get a really good map being developed and hierarchy being developed in the target area of that, so you can kind of see that hierarchically, so you don't have to do the heavy lifting of that. But you need to be clicking through things and seeing where things connect, looking at source code, reading the page, because you never know what little information. And of course, if you know those well knowns like robots.txt and secrets.txt and things of that nature, you can utilize that information and maybe go ahead. Yeah, I don't need the directory fuzz because it says it right here in robots.txt, do not go here.txt. And I'm putting that in the URL bar. I'm going there because you're trying to hide it. If you don't know what robots.txt is for, if you don't know what secrets.txt is for, maybe you don't understand that. And the first thing you want to do is just throw your tool at it and let the tool do the heavy lifting. The tool is going to be there for if your manual discovery isn't really revealing much, especially when it comes to a CTF, right? Because, right, if it's an online CTF, you could totally DOS the thing. If everybody that's doing the CTF is directory fuzzing, that's going to be quite a bit of traffic.
yeah.
So spend some time with the source code. Spend some time inspecting elements, reading just the text on the page. I was looking at each one of those cards. Everything on the cards on that landing site was like, check out sitemap XML, check out robots.txt. Like there was some big heavy hints in that specific challenge. So I don't think you left them without a witness there, sir.
Yeah. And there are a few more comments, and yes, so like you can find some other examples of binary defense, a bunch of other websites having their security.txt files. What are some other questions? Yeah, there was a question about what would be more efficient, automating or rating it. I mean, for this particular challenge, reading it is probably more efficient. There are a lot of things we can do to prevent, like we can do rate limiting. We can say like you only can send 5 requests per second, and so then your brute forcing wouldn't work. In general, we don't like disqualify or forbid it just because we can't enforce it. But generally, we design challenges in such a way so that if you throw a tool at it, it's not going to just give you the answer. You have to usually do some kind of manual work.
Good to know.
Yeah. So,
well, Roman, you think we've successfully explained this? I think we beat this horse pretty good, and
I think
everybody gets the idea. You should have learned about sitemap.xml, and now if you've never heard of that, or robots.txt and what that is, and some basic web app enumeration, you should be pretty handy to go at this point in time. Let's move on to the next challenge. And what level are we looking at with this one?
Yeah. So after this, the challenges start to get more difficult pretty fast. Just because we have 1,000 participants every CTF, we try to usually have at least one challenge that we think everybody's going to be able to solve, and then the rest kind of get a lot more difficult pretty fast, just because we're trying to make sure that there's only a few winners and not not everybody solves all the questions. And we actually had 4 people solve all the challenges this time, which I think for us that's kind of like the sweet spot, because we want to make sure that at least a few people solve all the challenges. And almost everybody solved at least one challenge, and then it's like a roughly even distribution. I guess for context, if there's a tie, the individual that ends up placing higher is the one that got to that point value first. And I think in our Flash CTF, there was only like a few minutes difference, or maybe even seconds difference between one of the 1st, 2nd, 3rd, 4th places.
Wow.
So, all right. Well, the next challenge, it's a binary exploitation challenge. I mean, it's not a really traditional binary exploitation challenge, because usually when you talk about binary exploitation, often people are referring to things like buffer overflows, or things where you have to modify the memory of the the binary during runtime and do something. This one doesn't quite go that far, but I mean, it's still a binary. You're still exploiting a binary, so it's binary exploitation.
Technically, it's binary exploitation.
Yeah, and so it's called satellite command. You can see that only third of that, as many people sold it as the previous one. But it says, we're prototyping a new system for grabbing telemetry from our CubeSat. Can you give it a quick test to make sure it's safe to run? Download the artifact here, and when you're ready, you can use our ground station to connect to it with Netcat, KubeNode, MCTF.io, the support. We had some issues with our Kubernetes. We're still not sure. Like, there was no load. It just didn't want to establish connections, and so that's why we had to spin up a backup instance of it. So I think if you try to connect into this, it's not going to work, but this will. Yeah, so you're given a binary. And a binary, for context, is just like an executable program that you're for those of you who are familiar with Windows, like .exe file is a binary, and for Linux usually there's no file extension, but those are called binaries. And often in CTFs, when you see a host name and a port, often we get a lot of support requests because people try to copy this, paste into a browser, and connect to it, and then they get an error that says, oh, it's not working. That's
I
why,
love
like,
where their
usually
head's at.
yeah, we usually explicitly tell you which tool to use, but not every domain and a port is a website. So the way you connect to it is using like a raw TCP socket and connection, and then NC or Netcat is the tool that you would use to do that. So just to show you, I'll open up the terminal. And if I paste in the command, it will launch this. It'll launch the program and let me talk to it. You might have seen this. Do you remember that, like, there's a Star Wars movie that you can watch in terminal?
Yes, it's a
using
telnet. Yeah, you telnet
Yep.
into the server, and it plays the entire A New Hope movie in ASCII text. Yeah, it's crazy,
Yep.
but it's kind of fun.
So the same concept. You're just using, connecting over something other than a web server. So there are a few different ways to approach this challenge. You are given the binary, so it's a program that gets executed. So I can download it. Let me just copy a link. I'll So wget is a command that you can use to download files, and I just copied the link. I'll run unzip on this file that we just downloaded. I just reinstalled my operating system recently, so I haven't actually had
You
a chance
too, huh?
Yeah. All right. Well,
it's always fun getting things back to what we feel is normal, and then those things don't pop up until you need them. Like right now, it's like, oh yeah, you didn't get unzip. Well, unzip that's for professionals.
Yeah. So this is a file that we've given you. It contains 3 files. It contains a challenge, so we can use the file command to see what the file is. So it's an executable. ELF usually means that it's for a Linux system, x86 64 architecture. We've also been given a Docker file, which is just a text file, and we're also given a flag.txt file, which is also just ASCII text. So I can look at the flag. It will just give you a fake flag that's not actually the answer. So actually, in this competition, one of the challenges we accidentally did give you the right flag, so we had to update the zip file in the middle of the competition and reset the flag. But it happens.
How often do people submit the fake flag?
Well, they do submit the fake flag quite often, and we do get some support requests about it. We try to make it explicit that
It
it
does
is a
say
fake flag.
Yeah.
But I mean, it also does really look like a real flag. And so I mean, I can see. I mean, like if I was participating, I would try it. I mean, I would submit it. I probably wouldn't submit a support request when it doesn't work, but I would
Yeah.
I'll definitely submit it and see what happens. Because sometimes like overthinking is definitely an issue in CTFs when you've been doing this for a long time. So a Docker file, it's essentially like a playbook for setting up a container used by Docker. And Docker is just one of the tools that one of the ways to, I guess, orchestrate, to spin up containers. And so if I look at it, well, let me pull up something better than that. Already downloaded Docker file. It tells you how I guess the container, for all intents and purposes, you can treat this almost like a base virtual machine. How it's running the program that we give you. So we can see that it creates these directories on the system. It writes these files to these different directories. It copies over the binary onto the container. It copies over the flag into the container. And then it runs it. Yeah, so breadbone jail is a special kind of image that we use to isolate different users when they connect to the system. And so by default, the way it's configured to run is if you put a file as /srv/app/run, it's going to execute it because that's how it's configured, what it's configured to do. But this is I guess the playbook for setting up this virtual machine. And so this container. And so when you connect to it using netcat, come on, okay. When you connect to it using netcat, what happens is your shell sends a TCP packet to the server, and the server runs this binary, and then it prints out the output. And then when you type something here, it's going to send the output back, and so forth. And so instead of connecting, usually you only connect to the remote server when you actually solve the challenge and you already have a working solution. What I'm going to do is I'm going to simply run the binary. Okay, I know that this binary is safe, so don't just run binaries that you get from from CTF competitions like this. Usually, you should use a virtual machine. I do know that it's safe, so I feel comfortable running it. But this gives me the exact same output, simply because the binary that we gave you is the same binary that you get to when you connect to the remote server. There are a few different ways to approach this challenge. One is you can analyze it. You can run things like strings to kind of print out. Okay, so here, if I just open it up in text editor, it's going to look like gibberish because it's a compiled binary. So simply looking at the file is not going to get you far, and so that's why you have to use some different tools to kind of help you understand what you're looking at. And usually the first thing you do is static analysis, or static or dynamic. But some examples of static analysis would be running strings against the binary, which just prints out all the different printable sections of the binary. Often it's not very useful, but sometimes it is, because it might, sometimes you will see the different like inputs and outputs that it has. You can also use tools like objdump. I always forget I think it's -E. I always forget the flags. Oh. objdump. Yeah, so this one, disassembles the binary and tells you I think I forgot a flag. I think objdump E-A, maybe. Let's see. Okay, it's a big binary, but somewhere at the top there's probably some actual assembly. You can also use some dynamic analysis. So static analysis is you're analyzing the binary without actually running it. You're just looking at the code and you're trying to understand what's happening. Dynamic analysis is you run the binary and then you try to observe what's happening while you run it. So using things like strace, ltrace, kind of the most basic ones. And so I can use strace against the binary, and it will give me all the system calls that are made. So like, write, read, and so forth. Another common tool is Ghidra, also for static analysis. You can put in the binary, file, import, binary, analyze, and if you look at the main function, you can see you can see a version of what the source code might have looked like, and kind of get a sense of what's happening in the program. And so for this particular challenge, you don't need to do any of that. The easiest solution would just simply have been to run the binary and to try it. And so here we're given different commands that we can run on this satellite. Status, just print some text. Help prints the available instructions. Exit, welcome. Exits out of the program. And then scan, if I just run scan, it tells me I need to specify a directory. These are available directories. Let's try payload, scan payload. It prints a debug statement that says we're executing command ls-l satellite payload, and pipe the output to null. If I, yes, so seeing something like this in a challenge it's a big red flag. What we can gather from this is that whatever we put after the scan, so in this case the word payload, it gets put in right here. This command gets executed on the terminal or in the shell, and well, I guess we don't see the output, but the output gets printed somewhere. It gets piped to null. We can try this again. So for example, instead of payload, which was one of the allowed subset available directories, I'm just going to put something random. And as expected, we see that even though it wasn't a valid directory, it still puts in as part of this command and gets executed. If you look at Ghidra, you'd actually have seen the exact same thing, where let me see if I can zoom in. Yeah. No, it's zooming in the wrong things. Oh no, it's just slow. Okay. It has this command, and it uses format string to replace this %s with the input that you provide after the word scan. Okay, let me see. Sam says, so Samantha or Shaden, she's actually the one who made this challenge. So I can, she knows what she's talking about in chat. Let me make a directory. Let me run this challenge, and I'm just going to run scan without anything. Oh yeah, okay. So it so we do see the output. Yeah, and so you can look at Ghidra and you'll see exactly what's happening. For this particular challenge, I mean, this is definitely useful, and you can know exactly what's happening, but you don't really need to. You can kind of guess just by looking at the binary and executing it. And so if you do some research, you will learn about something called command injection. Command injection is a vulnerability where the program, whether it's a website, whether it's a binary, whether it's any kind of application, takes in the input that the user provides, maybe filters it a little bit, maybe not, but then it takes the input and puts it directly into the command that then gets executed in the shell of the system that's running it. We have a challenge in the anti-7 cyber range that has the web exploitation variant of it. I think it's called Botnet Center. Let's see, bot. Yeah, and so it's an online networking tool that just essentially takes in the input that you provide, and on the back end, it puts it, it concatenates the input that you provide to the tool that's is used to get the output. So for example, ping, it just runs ping example.com. and you can put anything other besides example.com. You can start putting, semicolons, ampersands, some actual malicious commands, and it's just going to concatenate them and execute them. So if you want to try this, you can try this later. But this particular challenge does this, through a binary. And so if we look at this, let me open up Notepad. We can see that this is the command that's getting executed. Using ls as is, we can't. So we have ls. We can put whatever we want in here, and our target, based on the Docker file, is to get this flag.txt file that's stored at srv app flag.txt. This is in the same directory as the binary, so we can use relative. We don't need to use the full path. So essentially, what we know is that we need to go after flag.txt. And so, what are some ways to get there? Probably the easiest option is, you have ls. What if we replace %s with something like, ampersand, or I guess, space. So ls runs, then we put in double ampersand. So if the command succeeds, we then run cat flag.txt. So let's try this. And the way it's going to work is, for example, if I put in this input, it's going to replace the %s, and the command is going to look like this. So it's going to run ls, and then it's going to run cat flag.txt.
And for those of you keeping score at home, that double ampersand is basically a logical and. It's saying, hey, run the ls command and run the cat flag.txt command. And if as long as that ls command runs, that cat flag.txt should also run.
Yep. And so if I copy this, if I put it in, well, I guess I need to use the word scan first. Enter. Oh, it says block term cat detected. Security violation log. Well, this reminds me.
So you're doing a little filtering there, Mr. Funny
Yep.
Guy, right? You got a filter going. Hey, you've got some. I don't like the word cat, because when you cat things, you might be reading files that you ain't supposed to read. So that's no bueno. You don't get to do that here.
And if you actually go through Ghidra, you should be able to find. So it has this function that says is blocked. And if you look through this function, you might have to change, change how these variables are rendered, but you'll actually see a list of all the terms that it's blocking. But once again, it's not necessary. You can just try a bunch of things, but if you want to, you can. And this reminds me on a Linux system, when you log in and you enter the wrong password, it just says, like, oh, or like you try using sudo, you're not a sudo, or this incident will be reported, or something like that. So in addition to cat, there's 100 different commands you can use to get the flag. So, well, let's try. So cat didn't work. Let's try something like head. So head is another command that prints the first few lines, I think by default 10 of whatever text file you give to it. And so, for example, let me just create a bunch of file with a bunch of lines. 6, 7, 8, 9, 10, 11, 12, okay, whatever. And if I run cat on this file, it's going to print the entire file. If I run head as df, it's going to only print the top 10 lines. I can also do tail, and that'll print the bottom 10 lines. You can change this. You can say I want to actually see the next 11 lines, but let's try this command. Head. All right. So scan. Head. Oh, head is also blocked. All right. So before we go further, let's just brainstorm a bunch of things. We can use head. We can use tail. We can use a command called grep. So grep is just a command to search for files, for things inside of files. But I can use grep dot to just search for anything in a file like flag.txt, and that would print me the flag. In addition to head, we can use sed, which I think is I forget what it stands for, but it lets you
Stream editor.
Yeah, it lets you replace things. So let's try sed. What's the I think just p. Yep, they'll print the flag. We can also use xxd to convert the outputs of flag into a hex dump. So a handful of different commands. So let's try grep. I'm assuming that the tail will fail because head failed. But let's try grep.flag.txt. All right, so scan. Nope. Scan. Let me paste the entire thing. Enter. Oh, so now it's blocking the double ampersand. So you know, when you're solving this challenge, we just keep going through a bunch of things. I know the answer, so I'm just going to kind of skip straight to that part. You could have tried, pipes. You could have tried, sending the output from one file descriptor to another. And there's a handful of ways you can, and I think all those would be blocked. The ones that I know for sure aren't blocked, and there might be a bunch more ways to solve this, but I know that there are two symbols that aren't blocked. One is and. What essentially this does is it puts the first command that you enter and runs it in the background. So if I just do this, instead of double ampersand, it's going to run this one in the background, and it's going to run the next one. It also doesn't block semicolons. I think semicolons, I'm pretty sure, just a way for you to end the command and go to the next one. But let's try the ampersand. Grab flag.txt. Oh, there it is. So it executed the command, and then it printed the flag. So we know that this works. So if now that we're able to do this locally, I'm going to connect to the remote server, 986, and I'm going to run scan this command against the remote server, and it's going to print the flag. So this is how you exploit command injection for this challenge.
Nicely done. grep was a great way to go. I saw sed, I think, was used in the write-up for it, and I was like, oh, that's an interesting way of going around it. And other characters that you might use for command injections. So anytime you see a program, whether that be in a web application, whether that be in a binary application, and you can tell that it is running, and sometimes there are telltale signs, like it's obviously giving you the output of things like the ping command or NSLOOKUP or other system tools that are happening underneath the hood that it's kind of leaning on to make the magic happen for whatever you asked it to do. Once you start seeing that output, you go, oh, is it really just running ping? Is it really just running LS? And that's where this output is coming from. It's a great idea to start trying to fiddle with the inputs you give it, and then throwing at things like what we saw today, like the ampersand or the double ampersand. So you either put things in the background or try to do a logical and, do this and that. You can also try piping the output from that command into the input of another command. Even if it has no bearing on the input of the other command, it'll still try to run that command a lot of times. So the pipe character is the one right above your enter key. So if you just hit shift, you'll see that straight up and down line. If you do two pipe characters, that's actually a logical or, which will say, we'll run this or run that. So it doesn't matter if the first one doesn't work. It will try to run the second one anyway, because it's this or that. And then, of course, our tried and true friend, which is the semicolon. You throw the semicolons, a great way to string commands together in multitude of environments. I think this works for Windows, Mac, and Linux. You just string together a bunch of commands. So it's what we call one-liners. Go look up one-liners, and you'll get some great tools, by the way, some great one-liners, which will allow you to do a lot of really interesting things. But basically what Roman could have done is string that together, made one big one-liner of do ls and then do this and then do that. Now you got to get around your filter when you start to see that filtering if you can't use cat. So that's why I really liked being able to use grep or sed, some other tool that probably wasn't getting hit by that filter. It just goes to show you, filters are nice, but filters, they can fail you, right? You got to be really robust and test against your filters to make sure they're catching every possible thing that you can at least think of. Get other people involved. What can you think of to try to bypass these filters? And then add that to the filter so the filter is more robust. So really cool challenge.
And I think in general, I mean, if you can avoid using filters, like, SQL injection is where, like, sometimes you see people, or like a cross-site scripting is the standard one. Often you see people escaping characters to avoid cross-site scripting. Those things are not, bulletproof. And so even if you think they are, if you thought of every possible option, and so like SQL injection, the best way to defend against that is to use, like, parameterized queries or prepare statements. Um, but 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 I guess in the real world, where you often see command injection is when you do some kind of like file conversion or like report generation. So for example, you might have a tool that lets you export something as a CSV file, or maybe like it lets you convert this output, the CSV file into PDF, or like, because often a lot of those tools that do file conversions, they are like shell commands. You might often see this with like networking commands, like where you're trying to do some kind of like ping or do a speed test or whatever. But it's a it's a real thing. I found a command injection vulnerability in the wild where I was helping test 2FA implementation for an organization, and the way they generated some keys is they would you put your username in, you would send a request to a web server. And I guess the developer didn't know PHP that well, but they really knew Python. And so they wrote the core of the logic for the website in Python. And then in PHP, they simply took all the output, concatenated it, and sent it to, to the Python script and printed out the output. And so, it's out there. It exists. And there was a question about, will this be replaced? Yeah. So this video will be on YouTube, unless I get too embarrassed and have to take it down, but I don't think I will. Um, but
I don't think that's going to happen. But,
yeah.
You're doing great. You're doing
So,
great. So now we've looked at a great command injection, right? And ways in which we can test for that. And of course, we found the flag. So very good there. Let's move on. What's the next challenge we've got?
yeah, and so the next few are definitely a bit more difficult. So I'm gonna not go into quite as much detail. So this crypto one, Shinoi's mirror, this one was actually intended to be one of the hardest challenges in this competition. We didn't expect a lot of people to be able to solve it. What ended up happening is ChatGPT has gotten really, really good. And so you can put in this script and this challenge statement into ChatGPT, and in my case, it gave me the correct answer on the first try. So it's unfortunate for us. I mean, I mentioned this before, but we don't forbid the use of ChatGPT, partially because one, we can't enforce it. We can tell you not to use it, but then if you use it, you don't tell us, and we don't catch you, like you end up getting an advantage. But also because, I mean, it's not gonna, like, ChatGPT is here to stay, or whatever LLM tool, it's probably here to stay in some shape or form, and we do want you. Oh, I probably shouldn't have told you about ChatGPT, but it was able to solve this challenge, and that's why you see so many people were able to solve it, because we don't know how many of them, but we know that at least a few of them were able to solve it that way. But if you look at the blog on our website, you will see the solution. Well, I guess I need to explain what the challenge is. Let me just read it. Shamir keeps getting interrupted while sharing his secrets. Download the challenge script here, and when you're ready, connect to the remote instance with Netcat on this host. Backup instance. So this is the challenge that I mentioned, where we leaked the flag as part of the zip that we shared, and so we had to replace it. But because the flag contained a hint, and just out of fairness, we did tell people what was there in case it does give them a hint. So we really try to be fair in these. So like, if we see a bug in a challenge during competition, often in a lot of cases we won't fix it, just because we know that some people tried solving it or solved it with that bug already there. It would be unfair for us to fix the bug for other teams that haven't solved it yet. But we're given the script. And it looks like, so Shamir, for those of you who don't know, so this is referring to Shamir secret sharing algorithm. I'll explain in a bit, but essentially generates, it has a secret, and the secret is the flag. And it shares some values from that flag, prints them to you, and your goal is to extract the flag. This program we can run on our system, or we can connect to the instance using Netcat. I guess I didn't copy it. It'll give you a public parameter number, and I guess, yeah, let's try sharing amount for, let's see, share amount, certain amount, get shares.
If you
So
could
I think
increase the
that's,
font size just a bit on that so we can, it's a little
yeah.
tiny. There we go.
So I guess let me quickly explain what Shamir's secret sharing is. So it's a way for you to share private information among a group of people in such a way that, for example, you must have a certain number of keys or of people in order to be able to get back to the original. I think if you ever used Vault, like HashiCorp Vault, it uses something similar for, like, generating, I think, master passwords. But essentially, let's say I have some kind of number that's secret, and I have 5 people, and I give each of these 5 people some kind of piece of information, and I want to make it so that if any 3 of those people come together, they'll be able to find the original. But if there are less than 3 people, they will not be able to. So that's kind of the idea behind this, and the way it works is based on polynomials. So let me. I used to love this website when I was in high school. It was really useful. But the way it works is polynomials. So for example, if my secret is 20, 20 would that would be the y-intercept of the which is the secret. And then if let's say I have a random, I generate a number like 4, and then x plus 20. So this is I guess is like a way for me to, this polynomial essentially represents the secret that I'm trying to share. 20 is the secret, and 4 is just a random number that's random because, that's kind of the way to encrypt it. Say, well, and I turn this into a function. Let's say I have 5 people that I want to give the secret to. So I generate 5 random numbers. I run this polynomial for 5 different random inputs. So let's say f of 1 equals 24, f of 30 equals 140, f of 9, and then f of 4. I'm just going to do 4 instead of 5. And then I share these 4 numbers with individuals, and I tell them that this is I guess this is a first order polynomial. I forget what number they start. Linear. Well, is this a first order? Okay, yeah. So it's a first order, and I tell everybody it's a first order polynomial. So if you just have one of these numbers, there's no way you're going to figure out the number 20. But if you take any of these 2 people, and you tell them it's a second order polynomial, and you give them, and you take any of these 2 numbers, you'll be able to plot them on the map, plot them on the graph, draw a line through them, and figure out exactly where 20 is. And so in this way, I share the secret 4 times, but in order for anybody to get it, any 2 people need to come together and do the math to get back to the secret. And so that's the Shamir secret sharing. That's kind of what this challenge is built on. The way it works is, if you look at the solution, I think we'll need to fix this at some point, but it's supposed to render like this nice math formula. But it, generates a polynomial. It has the secret, and then it prints out a bunch of numbers that are these secrets. The same way we have secrets right here. It prints out 5 of them, but what it does is that it adds noise to each of these numbers. So for example, if the correct answer was, for example, 24, you would add some kind of number to it and give you 30. And then for this one, it would add another number and give you 145. One of these is guaranteed to be correct. So for example, it's going to say 56, and then it's going to give you 36 plus 20. And so it's going to give you these numbers. And one of them is going to be correct. You're not going to know which one it is. And so you have to somehow figure out what the secret is based on a bunch of these numbers. And so the way you do this is because you know that one of these numbers is correct, you can write it out as a math equation. Let me see. So for example, if we know that it's a first order polynomial, so p of x is the function, and then ax plus b. So b is our secret, and a is the coefficient. This is also this is not the secret, but it's also secret. We don't know what it is. We're given a few of these numbers, and we know that, for example, p of 123 equals abc, or some kind of number plus unknown number. P124 equals whatever this is, plus, all right, I shouldn't use letters for this, and so forth. We know that one of these numbers is going to be 0, and one of these is going to be some other number. We can rewrite this in the form of like p minus this question mark. Well, I'll call question mark 1 and question mark 2. And so this one equals 0. Because if I move this to this side, P123 minus this is 0, plus this, let's see. No, this one equals, yeah, and then I subtract this, it's going to equal 0. And then P124, well, I guess I need to do this, minus, and then P124 minus this number minus this number also equals 0. And then you can rewrite this in the form of this equation. So since we know what the x is, we can do 123x plus 123a plus b, minus this minus this equals 0. And then I can do the same thing for here, 124a plus b minus this minus question mark, it also equals 0. And so we need to figure out, so what we're really after is a and b. But this looks like another type of polynomial. And essentially, since we know that exactly one of these is 0, we can multiply these equations together. And so if we take this, and we take this, and we multiply these together, we know, well, I guess we can move this to the side. We know that this is going to, the multiplication of these two numbers is going to be 0. Oh, come on. No, stop. Because we know that at least one of these numbers is a 0. And so this is just a multivariate polynomial. You can rewrite this. If you multiply this together, it's going to look like some kind of coefficient, a squared plus b, some coefficient b squared plus ab plus a plus b plus some other coefficient. And if you get enough of these, equations, you'll get a bunch of polynomials that you can actually figure out what these coefficients are. And that's where the Grosvenor basis engine comes from. And so it's just an algorithm that can help you identify these coefficients effectively. And so now that you know what these coefficients are, you can run this formula again. So the flag is long, but it's giving you smaller numbers, and that's because it uses a modulo to kind of limit the space of the numbers to reduce the size of the number. And you can use an algorithm called Chinese remainder theorem to essentially figure out what the original number is based on a few of these combinations of moduluses and remainders. If you want to look into more detail, you should read the challenge description. But I'll leave it at that. I'm not going to go into a lot more detail. Feel free to post questions in the MetaCTF Discord server if you have any more questions. But that's the challenge.
That you said this was a little more difficult. You were not kidding around. That was you said polynomial, and I just started bleeding profusely out of my nose. And it was like, oh yeah, I'm back in high school math. This is fun.
Yeah, I mean, it's definitely one of the more niche kind of categories. I mean, there's definitely real world applications of this, in cryptography, and yeah, I mean that is the cryptography category. But the same way for binary exploitation, it's also somewhat of a niche category. And so what we try to do is we in general in Flash CTFs we don't have really hard crypto challenges all the time. We cycle the categories, and so we might have like a really difficult binary exploitation some other month, and so forth.
Yeah. Well, I know we're starting to kill time a little bit, so we got to get through. We got 2 more to get done, so we'll probably go a little bit over.
Yeah.
But let's go ahead and jump into our next challenge and see what we got in store there.
Yeah, and so I'll try to be a lot quicker with these ones. But the next one is a forensics challenge, hunt and peck. I was going to type out the flag, but I forgot my keyboard. No worries, though. I figured out a way. Download the capture file here. So we're given some kind of capture file, and we know that the user forgot their keyboard, but they figured out a way to type something without a keyboard. And if we download this capture file, I think we already have downloaded, so I'm not going to download it again. I'm going to open it in Wireshark. And unlike the usual Wireshark views you see, this one looks a little bit different. And that's because instead of being a capture of a network traffic, it's a capture of USB traffic. You can look through the first few, I guess they're called packets. I assume if it's a USB capture, I assume they're still packets. You can look at the data and see that it's well, let's look at the response. Device descriptor. It's a Logitech G203 gaming mouse. Can I use? I really don't like using this. I think Power Choice has a better one, but the magnifying glass. But this is what. But you can see right here that it's a PCAP capture of the USB packets from this Logitech gaming mouse. And so if we start looking through a bunch of the other packets, we just see a bunch of interrupts. And if you do some research, you'll realize that's how the operating system, that's how the mouse sends signals to the operating system and sends a bunch of interrupts, and it says, hey, I moved the mouse this many character or this many pixels or units in this direction. And every time you move a mouse, it sends an interrupt to the operating system. And it does something with it. So the next step for this challenge was you could kind of go through and you could read up on the protocol that's being used and manually decode these numbers. I think each one of them just essentially says that the mouse was moved a certain distance, and whether or not the button left or right buttons were clicked, while the mouse was moving. You can find the documentation. There's probably some kind of RFC that tells you exactly kind of how it's happening, or you can find a tool that will decode this for you. And this is the one that we used. We found pretty helpful. It's a USB mouse PCAP visualizer made by Yiheng Wang, but it's just one Python file. And if you look through it, it uses PyShark to load in the PCAP file, and then it goes through, it splits it up into packets, figures out, let's see, parses the data from the packet, and essentially generates a report that says, hey, the mouse, like a CSV file that's easier to parse. So what we did is we took this file, and I already did the work. So we took the file, and we simply ran hunt, ran it against the PCAP file, so usb.pcap. Let me see if I can zoom this in. And the output file, let's say movements.csv. So it's going to go through. It's going to go through the packets, and it's not going to work. T-Shark seems to have crashed.
Thanks a lot, T-Shark.
All right, it doesn't matter. I do have it already generated. I can show you my bash history to prove that I ran the command. But essentially, it says that at this timestamp, the x coordinate changed by 1, the y coordinate changed by 0, and none of the buttons were pressed. So if I search for true, we'll see that eventually there are some movements where the buttons have been pressed. And if we do this, we can see that the button was pressed a bunch of times. Not the button, the mouse. So what essentially we can the library that we used already did the math, and it figured out where the mouse moved, and so we can simply take this and we can render it somehow. This part will require some trial and error, and just kind of maybe visualizing this data, trying to see what's happening. But the challenge description that we gave does give you a big hint. It says that you forgot your keyboard, but you figured out a way, and it's probably implied to type something without a keyboard. So you can visualize the data. So we have a Python script that simply creates a plot that looks like this. Let me open Explorer. Well, that's not much better. But you can see that it plots all of the clicks on a graph. What essentially the challenge is that the user, without having a keyboard, opened up on-screen keyboard like this, and typed in the flag, without using the keyboard, using the mouse. And so if we find a way to essentially overlay these mouse presses on top of a Windows or I guess any other kind of on-screen keyboard, that will get us the flag. You could probably do this manually. You may not have enough time to do that during a 2-hour flash CTF, like somebody mentioned. But another way to do this is to essentially generate maybe a small movie or something, a small video to do this for you. And you can find the script on our blog. But we essentially generate a video that looks like this, where we overlay these presses on top of just a random image of the on-screen keyboard that I found. If you play it, you'll see that the shift, you can see which buttons were pressed, and you can slow this down. You can see that shift is being pressed a bunch of times, and that's mostly because we're, that's how you can capitalize letters on the keyboard. Probably didn't need to explain that. But you can see M, E, T, A, capital C, capital T, capital F, curly brace, C, L, I, C, K, I, N, G, clicking, underscore THE the underscore KEYS keys. Clicking the keys was the flag. And so that's kind of the solution to this challenge. You just have to find a way to parse mouse movements and clicks. Yeah, and, I think that covers it. Once again, you can talk in the Discord server, and we can, either ourselves or somebody else in the server will be able to give you a little bit more guidance. And you're also welcome to publish your own solutions on these. And we've actually, so if my explanation wasn't sufficient, you might be able to find a few more people talking about it in a slightly different way.
I will say that, looking at some of these challenges like this one and the previous one, obviously there may be some niche to it. So you'd have to get up to speed with all the different specifics as far as that niche goes. But once you're there, once you kind of get acclimated to that challenge, it is definitely going to push you into expanding and broadening your horizons and your knowledge and your skills. And ultimately, that's what we do with CTFs. That's what they're for. They're supposed to be fun, kind of give you a little gamified version of a problem to solve, a puzzle. And then 2, you learn something new and you add that to your skill set. It might not be that we have, a script that overlays key presses sitting around in our back pocket that we use on a daily basis. But what it does do is kind of teaches you more about the different technologies that you're working with and gives you a deeper understanding. And then if you take that information and start to synthesize, apply it on the keyboard to finish a CTF challenge such as this, you'll have grown. And that's the idea behind it, I think, that you guys are getting at.
Yep.
One more?
There was a question. Yeah.
Oh, you have a question. Yeah.
There was
go ahead.
there was a question about the keyboard challenge and asking us to clarify the the locale. Yeah, I mean, we might do that. I think to some extent there's probably going to be a bunch of other examples where we just will forget to do something similar. So probably up to the participant to kind of assume it's either Great Britain or if it's English, and then maybe try a few options. But is the UK keyboard really that different from the US one? Let's see, GB on. Are they really that different? Oh, wow. Do you have Y's and Z swapped? Well, it might not have made a difference, but yeah, we'll have to look more into it. All right, so I'm going to jump to the next challenge. I didn't think that this one was intended to be the most difficult challenge, but I think it ended up being the most difficult challenge. I guess a little bit barely. But this is a reverse engineering challenge. And so what that means is you're given some kind of file, some kind of program, application, Android app, and you have to take it apart and figure out what it's doing. So if you download this file, well, let's do this. File, mutated. We see that it's also a 64-bit executable. If we try running it, I need to give it execute permissions. We are asked to enter the flag, and it verifies whether it's correct or not. So this is kind of a standard like flag checker program. It's a kind of challenge that you have to look at the binary, reverse engineer it, figure out what logic is happening in the background to generate the flag, and then kind of reverse the steps to find the original flag. So there are once again a few different ways you can approach it. You can run strings, you can run strace, ltrace. Well, I think it's statically linked, so not ltrace. But my personal approach is just to throw it into Ghidra and see what happens. Sometimes it's obfuscated, but sometimes it's not as obfuscated. And if you find the main function, we'll see that we have some kind of encoded shellcode. We XOR this encoded shellcode with 0x5a. And so I'm skipping a bunch of steps because I already know the solution. I don't have much time. But if you do a little bit more research and look through the assembly, if you look through the symbols, like through the different strings inside of it, you will see that essentially what's happening is the program runs. It has some kind of shellcode or some kind of binary executable data embedded. It takes the data, it XORs every single byte of it with this value 0x5a. An XOR is just a one-to-one like mathematical function that just swaps some bits, and you can it's an inverse of itself. So you can run XOR against the same they I guess encode and encrypted string and to get the original back. And yeah, Michael says flashbacks to loader challenge. This is pretty much the same thing. It loads in shellcode, decodes it, and runs it. So there are a few different ways you can extract it. You can try statically finding it. You can, in the solution, we have a script that will extract will find the encoded shellcode symbol for you and extract it, and then it will XOR the bytes with the key that we found in the code. And so what this program does using Leaf, it just takes in, finds the section, decodes it, pulls it out, decrypts it, decodes it, and puts it into a file. This doesn't look pretty, just because it's well, here. That's why I don't like VS Code, is because it doesn't let me look at files that the way they were supposed to be looked at. Well, I guess that's objective, but this is what this file really looks like. It's just a bunch of bytes that if you are essentially assembly machine instructions, and it's not pretty to look at, and so we can use a tool like NASM. Let me find it. Oh. I used it somewhere, but essentially there's you can disassemble this series of bytes into assembly, and then looking at assembly is a lot easier than looking at raw binary data. And so if you use that command, you'll get something like this, and this is just a bunch of assembly x86 instructions that do a bunch of random things and somehow, somewhere, verify what the flag is. If you go through this code, you'll see that a bunch of these sections are actually just irrelevant. Don't do anything. They might move value to the register. They might add something. They might subtract something. They might, multiply something. But in the end, a bunch of these functions are, after they execute, nothing happens. They just move some numbers around, but at the end, nothing changes. And I can find an example in the solution. Let me see. Yeah, so like this example, this one adds a 0 to register 11. This one runs bitwise OR against this register. This one multiplies this register by 1. This one subtracts 0 against this register. Yeah, and so you can see that all of these assembly instructions do nothing. And so this is an example of obfuscation. This binary, these assembly instructions were obfuscated such that the core thing that we're looking at is harder to find. And so if you go through this, you can delete a bunch of these sections. A lot of them are repeat, so you can find them and delete them manually. But at the end, you're going to come figure out something that looks more like this. And this is the assembly that actually does the flag checking. And so what's happening here is it takes in 3 bytes at a time. It packs them into, I think, some kind of data structure, maybe an integer. It multiplies them by this value. It XORs the result of this multiplication with this value. And then it compares it against some kind of dictionary that we have in memory. And if it fails, it just ends, and if it succeeds, it keeps going. And yeah, and so essentially this is kind of the main thing that you're looking at, and we have this stored in the file. The way you can reverse this is you take the just reverse the steps. One thing you'll find is that since we're using only like a small integer type, or like a small data type, the value gets cropped after multiplication. So you lose a few bytes, but you can use like a mod inverse formula to figure out what the original number was. And so yeah, you take the packed binaries, you split them back, do the math, and you get the answer back. Yeah, I think that covers this challenge. Very high level.
Yes, very, very high, but well beyond my pay grade, that's for sure. But if you're at that level where you're doing some binary exploitation, you're doing some reverse engineering, you're messing around with assembly, then this is probably a challenge that you're like, oh, got some assembly going on in there. Oh yeah, obfuscating things our way. I see what you. I'm ready to go. Okay, but that's not me. That's not this guy. I'm not there yet. Hopefully one day I'll get there. I got some skills to learn myself.
And you certainly can. And usually what happens is that you never really get to a point where you can. I mean, there are some people that can do all of them, but generally you kind of start specializing. Like, oh, like I'm generally good at web. Others are really good at, like, I know some people who are really good at binary exploitation, and there's no way even well, maybe if I did nothing else, like I'd probably get to their level, but some of them just have like a natural talent for this.
They do. You know those people when you meet them too. You're like, oh, I got you. You're the top 10% of the top 10%. I see what's happening here. I'm down here, you're up there, and this is how the order of things are. That said, we have finally gotten our way through it, and that's awesome. Thank you so much, Roman, for helping us understand, at least to some extent, each one of these different challenges and where we might need to know and kind of work with to be able to solve them. And of course, there's always the blog that's out there with the solutions that are readily available. So if you want to go out there and study those and maybe pick up a new skill or two, you absolutely can do that. We do want to take this time to acknowledge our winners of the MetaCTF challenge as well. Roman, you got some names for us, if I'm not mistaken.
Yeah, so Flocto, Coriel, Sendline, S007, they all solved all 5 challenges, I'm pretty sure. Yeah, they solved all 5 challenges during the competition. And so
wow,
they are they are ranked based on how quickly they got to that point. And so Flocto was the first one to solve all 5, Coriel was the second, and so forth. Yeah, congratulations. And we had a DEF CON ticket as one of the prizes. So I don't know, I haven't seen we sent out a form asking like, oh, like which prize do you prefer if you end up winning? I don't know who picked it, but maybe we'll see one of you at DEF CON.
That would be super, super cool. For those of you going to DEF CON, keep an eye out for that MetaCTF winner. Very, very cool stuff. Well, Roman, thank you again so much for your time and your expertise in these challenges. We look forward to seeing you next month, where we do this thing again after the Flash Challenge is over. We'll get to announce some more winners, learn a new skill or two maybe as we look at these walkthroughs. So looking forward to seeing you then. But that calls it a day for us, kiddos. Thanks for joining us, everyone that's out there in the chat. Appreciate all your engagement with us on that. Definitely be sure to follow us and MetaCTF and all our socials and all the things that we're doing. Get involved, get engaged. We'd love to see you there. Until next time, have a great day.
Thanks, everyone.